Welcome to today's webinar. The topic today is new features in steel joints add-on. My name is Andreas Hörold. I am responsible for marketing and public relations in the company Dlubal Software. Yeah, for instance, the Dlubal website, the German and English webinars, newsletters, customer projects, and so on. I will be the moderator today and also the presenter, and my two colleagues will support me and they can introduce themselves. Walter, it's your turn. Your microphone is muted.
Yes, thank you. Hi, my name is Walter Fröhlich. At Dlubal, I'm responsible for customer support by email and phone. Furthermore, I'm a member in our development team for the add-on steel joints. Today, I will answer to your questions during the webinar.
Hi, my name is Lucas. I'm working here as product engineer and customer support engineer, usually with the focus on the steel design and the interfaces. I will also assist Walter in regard to answering the questions.
Okay, for the attendees who participate the first time, I will show where you can ask questions. At first, we switch off our webcams so that the attendees can see the full screen. Okay. Yeah, that's the control panel. You can see that on the right side of your screen. You can show or hide it with that arrow here, and then you can enter a question here, and my two colleagues will answer you. If you don't get an answer during the webinar, because there are too many, you will get an email afterwards. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. To the agenda today, the first point is I introduce a quite new feature, the plate editor. Now, I showed it on a complex example. I will enter the plate here and cut it, and show you the finished connection. So the first point is the new member editor component. I will introduce it as well on another example. And then I introduce the new feature, the initial stiffness, that's now possible to calculate in RFEM 6, in the add-on steel joints. Okay, then I turn to RFEM 6. That's a bridge. Maybe at first I show you where I have this. Oh, sorry, I have to open a document. Just a moment. I forgot to open it before the webinar. I will show you an image from the internet where I found the connection. So I have to copy that here and then enter it. Okay. I found this connection from a steel bridge. And I would like to remodel it, that you can see the possibilities of our steel joints add-on. You can also design such complex connections. I will enter only a part of this connection, and at the end I will show you the finished model. So let's start. I've already activated the steel joints add-on here in the base data, left above, add-ons, and then steel joints. And I had to select the standard Eurocode 3, also the American standard AESC 360 would be possible. Okay, so then types for steel joints in the navigator data, steel joints. With a right click, I can select new steel joint. So in the preview, you can see the whole steel truss bridge. I have to select a node. I select node number 1. the edge. So I'm going to zoom a little bit in. Yeah, I can leave the member names here. If I click on it, you can see it's selected in the preview. Yeah, I would like to rename them for a better overview. From member to diagonal, I enter only dia 1, dia 2, dia 2, then horizontal beam and cross beam. So, okay, then I turn to the next dialog, members. At least one end needs to be supported. I leave that setting. And then, yeah, the most important dialog, the components. So, and I start with a first cut. I would like to cut the horizontal beam. That's why I insert a component. Then member cut. Which member needs to be cut? The horizontal beam. You can also see that it is selected in the preview window and cut via diagonal number 1. Sorry, again. Then perpendicular and the closer end, but we need to enter an offset 195. No, that's not correct. Just a moment. Okay, at the closer, the farther end. Okay, and no offset. That was wrong. Sorry. Okay, now you can see the cut. The farther end of the diagonal number 1. Sorry. So then I insert the next component, also a member cut. I will need to cut the diagonal number 1 and cut via member. You can also select auxiliary plane or by plate. Yeah. And this time by member and the horizontal beam. Didn't get it. Okay, horizontal beam. Then perpendicular. And an offset of 195. Okay, maybe a small hint. If I are too quickly, you will get in the next days an email with a link to the recording and to the models. And if you want to enter the same connection later, you can use the recording and the models. Okay, so, and another hint, if you enter such complex connections, I would recommend to draw this connection before, that you can measure on the draw and then enter the values here. Okay, the next member cut, I select this line here, and with right click, I can copy the components at the end. And I only change that line here or that entry to diagonal number 2. Only a small step. Yeah, we are finished with the member cuts or cut. And I enter sheet. You can see the different components here. We will use a lot of them. today. So that's the plate. Okay. The thickness of the plate should be 17. The width 750.8. And this one 800. Okay. Then the origin should be the member plate. I have to enter the material. Sorry. So then the values are correct. So, and then member plate. I didn't get it. And the horizontal beam and web 2. Okay, I can show you where it is now. So you can see it. So, and if I enter here, the half of the plate and the half of the web, minus 40.5, it will be moved on the outside. So, and I have to enter a value here. Okay, this position is correct. So then we add a new component, the plate cut. Okay, plate 1 by member plate, the horizontal beam, and the flange 1. Okay, that's quite okay. And I would like to enter a weld. So, weld. Not a double filled weld, but a filled weld on the rear side. Yeah, this one wouldn't be possible. Okay, and I enter another value here for the weld, 8 millimeters. Okay, then the next plate cut. Yeah, plate cut. Diagonal number 1 and the web. Okay, but the rear and yeah, the closer end, but an offset of minus 125. Okay, yeah, that looks already quite good. So, and now we turn to the plate editor. I enter a new component, the plate editor. Plate number 1. And what is new is the opening, and we will use the opening. So, yeah, you can enter circles, rectangles, polygons, hexagons, yeah, these 4 possibilities. And I use the hexagon. Yeah, and yeah, you are quite flexible because you can enter the values here. Yeah, it can create any hexagon. So 300.11, 150, 260, 400 as offset or as center point. Okay, and yeah, with this plate editor, you can enter such things. You can also enter a rounding here as you want. So then another plate editor, I have to cut this triangular elements here or parts of the plate. So then the next plate editor. So then plate 1, chamfer, 7.885, 120. Okay. And then I don't want to cut our corners, only 2 and 1. 1 and 2. Okay. So, and that looks quite good now. The next step would be to enter our welds here, and then a lot of copy and paste. I can show you how to, for example, copy and paste this plate here. I would select the last 4 lines, or what is necessary for the plate, and then copy components at the end. And I only have to enter or to change or modify the plate 2. I show you this view. So, and I only have to enter 14.5 and the other web, horizontal beam and web 1. And now the position is correct. So, then it would be necessary to create other plates and fasteners and so on, but that would take too long. I switch to the finished model. Just a moment. That's the finished model of the steel truss bridge with the 4 edge connections here, also of the cross beam. You can see the fasteners and so on. And if you want to see the results, you can check it here in the navigator results. You can see the single components, the fasteners, for example, only the fasteners, and the design ratios. In the table below, you can see the different design checks ratios. Maybe I'll check also the welds and so on. As I said at the beginning, you can download this model from our website. At the end of the webinar, I will show you where I can find it. I close the model, and turn to the next model. So that's a multi-story frame with different diagonals. This diagonal is an I section, whereas the same I section, and this is a rectangular hollow section. That possibly makes no sense in the practical use, but I would like to show you 3 different connections for diagonals, and the first one and the second one with the member editor. So I start with that point here, steel joints, right click, new steel joint. I select the node. So, okay. So, and I will rename the single members as well. Another possibility is also you can change the order of the members if you want. Maybe I can show you how to do that. That's the column, and should the next, in my eyes, should be the horizontal beam. Horizontal beam, okay. So this one should be the diagonal. And the last one, the upper column. Okay, that's a possibility. I will rename one. So that's the column below. This is the horizontal beam. Diagonal. Then the column above. So then we turn to the members, at least one, and should be supported. And I also have to select continuous, that we can connect the horizontal beam to the continuous column. It didn't get it, just a moment. Okay, now it's correct. So then components. I start with an end plate. I enter this component, end plate, the horizontal beam. So I zoom a little bit in. And the reference member should be the continuous column. So the same material as for the members. The thickness should be 20. Then 200. So, and then I can show you the left and right offset. 5 millimeters and 5 millimeters. Okay. So then the bolts, the diameter should be 16 and the strength grade 10.9. So I only have to enter the horizontal spacings, and we got 5 horizontal spacings. I can also increase the window. So that we can see all values here. So, okay, and 60, 50, 240, space 100, 100. Okay, so that should be all to the bolts. And I only need to define the different welds. 5 for the flanges and 4 for the web. So, okay, that's all for the end plate. And now I enter a haunch here. Maybe I show you this view. Next component, haunch. So where should the haunch be placed? On the horizontal beam. And the web is okay. Plate. So, and then end plate 1, plate 1. That's okay. So material, the same as for the members. Then at the bottom, okay, but not parallel, but inclined. So then the different values, 225, 200, 100, 125. That looks quite good. We only have to define the welds for millimeters. Okay. So, and now we need to cut the diagonal. Yeah. Diagonal is too long. You can see that in the preview. So that's why we enter the next component at the end, a member cut. So as I already mentioned, the diagonal by member column, then plane is okay, closer end, and but not parallel, perpendicular. So with an offset of 100 millimeters. Okay, that looks already quite good. So the next step is the member editor. Now that's a quite new component. So I add it at the end. Member editor. So then member plate is okay. Diagonal flange 1. So, and with an end offset. And the offset should be 130. Now you can see that in the preview window, what we did, we cut that flange. So that was the upper flange, and now we would like to cut the lower flange. That's why I copy that component, copy components at the end. So, and for flange 2, diagonal flange 2. Yeah, that's all. So now you can see that the web is not exactly in the axis of the haunch. That's why I defined a small eccentricity in the global RFEM model, that the connection will be fine. Just for your information. Okay. Yeah, last but not least, we have to enter the fasteners at the end. I will enter a component, the fasteners, the last component in this dialog. So then component plate of the haunch, and then member plate, and diagonal and the web. So those components should be connected with the fasteners. Then the position diagonal web. The diameter should be N14 and the strength grade 10.9. I have to enter the spacings here. Okay. Also, there should be 2 fasteners, then 30. Okay. Yeah, that's all. You can cut such member flanges, for example, with the member editor. In the next connection, I would like not to cut this part of the flange. I think it's not necessary. And better for the flow of the forces. That's why I copied that connection here, or that steel joint with that button at left at the bottom. Copy selected joints. So, and I select the R1 node number 5, and I delete node number 3. So all was copied, but I need to modify the member editors. So I start with member editor 1. I zoom a little bit in that you can see what I do, and in the preview window I change the end offset to notch. Okay. Enter dimensions here. 1.1. Okay. So, and now I don't want to cut all, but only part 4. So, and now this part remains. That's what I would like to do. The same for the other member editor. Notch. And the same distances here. So, and also only part 4. So you can see, almost the same steel joint, but with this part of the flange. You can see how flexible you are with the steel joints add-on. So then another example with the rectangular hollow section. I copy the connection again. Select this node. Okay, and delete the node number 5. So then the components. Now we have to modify something. We can use the end plate, the haunch, the member cut, but we delete these lines. Okay. And I have to modify at first the member cut. So I have to enlarge the column 240. The diagonal, sorry. That's okay. So just a moment. So then I have to enter another member cut to enlarge the column here. So member cut column by member by horizontal beam, plane the farther end, and with an offset -50. So that looks quite good. Okay, then the next component, plate. This component, plate. This should be the plate in the rectangular hollow section. There will be a weld and a member cut, and we connected this with fasteners or with bolts. So then material, the same material, thickness 5, and width and height. Then plate. Which plate? The haunch. I didn't get it. Okay. So, and we have to enter the dimensions or the displacement. 63, 45, 7.5, and we have to rotate it 45 degrees. So, and yeah, that's quite okay. So, and now we have to cut out this part here, where the plate is. So that's why I enter a member cut. Diagonal by plate. And plate 1. So then by surface, that's quite good. And we have to enter the welds for the flanges. So maybe I show you the result. Right at the bottom, you can click on that button. I have to move it a little bit, and you can select and deselect the different components. And if I deselect, for example, the plate, okay, and from the member cut, the welds, now you can see that cut here. That was the member cut. So I select all again, close this area of the single components. So, and we have to enter the fasteners. So at the end, I add the fasteners. Which components should be connected? The plate, plate 1. And the haunch. So, okay. And we only need to define M12 4.6 is okay this time. Then we need to enter the spacings, 35, 60, and yeah, that's quite okay. Now you can see the connection is finished. Yeah, you can see with these examples, you can connect different cross sections as diagonals. You have got all possibilities. Yeah, okay. Only some examples. I turn to the last part of the webinar today, the initial stiffness, a quite new feature. I open another model, a simple steel frame. And I would like to show that on that example with a rigid connection here at the end. And I enter a DSTV, a standardized connection, where you can see the initial stiffness. I show you that in RFEM 5, we had the RF joints add-on. That's a DSTV connection. I can show you the general data, typified joints according to DSTV. And I designed it, and you can see the initial stiffness from the guide, 33.6. And we remodel this connection in RFEM 6 and compare the initial stiffness of the DSTV guide and from the steel joints add-on. So I turn back to RFEM 6. I create a new steel joint. I can select the two nodes. Okay. So I rename them again, the column and horizontal beam. Yeah, and that is a new component here, the additional analysis, a new possibility or new feature in the steel joints add-on. I've already renamed it. You can go to the dialog. That's the new feature, initial stiffness. And where already the stiffness diagram and the possibility to generate hinges in global model in gray, those are features that we will implement in the future. Okay, so we would like to calculate the initial stiffness of a certain connection. So members, next dialog, at least one at end should be supported. So, and where is the stiffness analysis? And if you want to analyze the stiffness of the connection, you can select here normal forces, the moment my and mz, to compare it with the DSTV guide. I select only my. But you can also select all. So that's all for this dialog. I enter the components. And this time I go to the components library, a quite large library with predefined connections. Here the main category is rigid, then pinned, the truss connections, bracings, and we would like to use the rigid connection. beam to column and the end plate column stiffness. Then if I select apply template, then the components of the single components of this connection is loaded in in our C joints add-on, and then you can see in the preview that looks that the connection looks quite good. We confirm it with OK. And we have to enter or modify the connection according to DSTV. First, I I modify the member cut. I enlarge or I increase the length of the column. I can see that in the preview. We will have a bolt or bolts also over the flange. That's why I have to increase the height of the column. So then I have to modify the end plate. The thickness should be 35. Then I use this time the dimensions and positions to enter the values from the DSTV guide. 340, 105. Okay. So the diameter should be M24 and the strength grade 10.9. So then the different values from the DSTV guide. (55), 115, space 90. And the last dimension is calculated automatically. So that's quite all. Note the flanges, the welds, sorry. Yeah, but before I do that or enter that, I have to uncheck that the shear plane is in thread, because according to the DSTV standard, in the DSTV guide, the shear plane is in the shaft. That's why I uncheck this. So, and now I enter the welds of the flange, 8, 5, and then this flange, 8, sorry. Okay. That's quite all for the plate. That's okay. So stiffener, we have got 2 stiffeners. I delete the second stiffener. So modify stiffener 1. At first, I select side, node the position, both. Now, did get it? So both. And now I can only do one entry, 16 millimeters. Yeah, according to the DSTV guide, the thickness of the stiffener should be minimum of the thickness of the flange of the horizontal beam. Okay, that's all. I only have to define another weld, 6 millimeters. Okay. And with this button, you start the calculation of the stiffness. As you start the analysis of the stiffness. It would take half a minute. I skip, or I turn to an already calculated model, and You can see the results of the stiffness analysis. Yeah, and there's the value for SG-INI 33.2. Let's compare that again with RFEM 5. 33.6. Yeah, nearly the same value, but yeah, the advantage of the steel joints add-on, you get also the rotational stiffness of the M+. When you have got positive moment, there is of course another initial stiffness. Yeah, and you can also get the results for the stiffness of normal force and so on. Okay, to consider the initial stiffness in the main model, I copied that frame to show you the difference. So right above, move copy, I create a copy, 15 meters in X direction, and with loading, also copy including loading, that we get the same results. Let's check. Okay. So, and now I double click on the horizontal beam. I select hinges. So, and I define the hinges. Around the y-axis, you can see that in the preview, and I enter the rotational stiffness in meganewton per rad. So the default setting is kilonewton meter per rad, and I changed it previously that I can compare the entries better with the DSTV guide. Okay, the beginning and the end. Okay, so and let's calculate all. So, and if you can see, or you can see that we considered in the right frame the spring, the initial stiffness, and you can see where difference of the field moment and the moment at the end, or at the end of the horizontal beam, or at the edge here, a difference nearly 10%. You can see how important it can be to consider the initial stiffness. It's defined in the Eurocode 3. Okay, that should be all to the 3 points. Before I show you where you can find the recording and the model, I turn back to the PowerPoint slide. If you want to get a free product demonstration for this add-on or another add-on or RFEM 6 or RSTARP 9, just contact our sales team. Or if you want to get a non-binding offer, just click on that link here or scan the QR code. You can download the PowerPoint slide from our website. I will show that on our website. Just a moment. I turn to our website, dlubal.com, and under news and events, you will find the webinars. That's today's webinar. That's the webinar of the next week. I will be also the presenter, the most frequently asked questions answered by Dlubal support team of July. That's the beginning of July. So then the week after next week, the stress strain analysis and so on. Okay. So I click on the webinar of today. In the next days, you will get an email with a link to that page and you will find the recording here. The PowerPoint slides are already here. And when you scroll down, you can find all the free models. You can see in the preview that all 4 connections are finished here. Maybe another hint, if you have got or have calculated quite interesting customer projects with our software. Under downloads and info, you can find our customer projects. And if you want to submit your own customer projects, those are the last projects. And if you want to submit your own customer project, just click on that link and you can fill out this form, or you can write us directly. It's a good advertising, a free advertising for your company. We link to your website. Our website is often visited and we have a very high Google ranking, and that can improve also your Google ranking if we link to your website with this customer project. Okay, that's actually all for today's webinar. Maybe a last hint. When you leave the webinar, there's a small survey, only some questions. You can score the webinar. Just note that the worst score is 1 and the best score is 5. As you give stars. You can also enter wish for future webinars if you want, but if not, you can enter any sign. If you don't have any wish for future webinars, it would be very nice if you fill out this questions or score. It takes you only 1 minute, I think. Okay, that should be all for today. I thank you for your attention. Thanks to my 2 colleagues for answering the questions. Maybe we meet each other in a future webinar. Have a nice day and bye-bye.